we're going to take a look at what functions are, and there's a pretty basic definition that basically just says this. There's a rule where each input has exactly one output. And we'll talk a lot more about this on 7.2, that lesson. But today I just wanted to get your feet wet to start learning what the basic definition of it is. And we'll talk more about inputs and outputs, but as far as that one output thing, that is important, but we really won't get into why until the next lesson. Moving on though, let's take a look at this situation right here. Let's just say that I gave you a graph, a line that's been graphed. And if I said, could you form an XY table from the coordinates of those specific points labeled, you hopefully would be able to say, yeah, no problem. Because this point right here, the X value is at 0, so I'd put 0 right here, and my Y value is at 2. And my X value for this point right here is 1, and my Y value is 3. And at 2 is my X value, but the Y value would be 4. And listen to what I'm going to say here very carefully, because I'm trying to foreshadow what's about to happen here. My input is 3, and my output would be 5. And I could have said that with all the other points, but basically it's this basic idea that we could rename the X values as input values or inputs, okay? And this would be my outputs. And actually, let's just make that singular. So we got our input column and our output column. Okay, so it's another name. And that kind of fits into this idea of functions where we have an input that's 0 and we have an output that's 2. We have an input that's 1 and we have an output that's 3. But we've not changed or forgotten anything that we've learned in the past. This is still known as X's. This is still known as Y's. It's just now we kind of have another nickname for it. To kind of drive this point home, I usually like to talk about milkshakes. So let's talk about inputs and outputs on making a milkshake. A lot of times I'll bribe my son to do something at home. Okay, and I'm not talking about homework. I'm not talking about behaving. I'm talking about I ask him to do something that's kind of tough. He's still kind of small, and so I'm just like, hey, would you do this? If you do this, I will give you a chocolate milkshake. And he's usually like, yeah, no problem. I'll go practice basketball for the next 3 hours. You got it. So here's my input items. I need ice cream. Whoops, just misspelled that. We've got ice cream. We've got milk. And because I use vanilla ice cream, I normally use chocolate syrup too. Okay, because you like chocolate milkshakes. So there's my input. I put it into this big blender. Okay, so I'm just going to have this as a box right here. And then my output, after I kind of mix it all up, it becomes chocolate milkshake. So it's this basic idea of you put in some raw materials, some inputs, something's done to it, and then out pops your product, your output. Okay, so that's the basic idea of inputs and outputs, and we'll come back to this idea later. So that's a key idea. We already are familiar with our x's and y's, and we can take them from a graph. And we can also call our x's inputs, and we can call our y's outputs. Well, we can also rename it the domain, and we can rename this one range. Okay, and so to kind of reinforce this, I've got a nice little reminder right here for us. Things to remember: other names for x's and y. I can call an x domain. I could also call the x or domain an input. And I could call a y, instead of using y, I can call it range, or I can call it the output. Okay, and we need to know those interchangeably. They're just nicknames. For example, if I had a son named Samuel, that would go on the birth certificate. However, when he was younger, I would probably call him Sammy. Okay, and at the same time, as he got older, he'd probably want to just be called Sam. So these three names all mean the same person, and there's just different connotations or different versions of them. Well, here the Y would be like the Samuel, the range is like the Sammy, and the output's like the Sam. Same thing with the X's. The X is like Samuel, domains like Sammy and inputs like Sam. They're just nicknames. They all mean the exact same thing. And so if they talk about domain, don't be mystified about it. Just know that they're talking about the X. And if they talk about the input, don't freak out. Just go, oh, they're talking about X's. And I know all about X's because we've done that linear chapter and we've also done our system of equations. Now, moving on, when we start taking a look at the basic questions that you're going to be asked, you're going to be given a table. Well, here's your X's and here's your Y's. These are ordered pairs. That 8 is paired up with a 14, and we could graph that point. 10 and 18 and 40 and 78. This one's kind of important to remember. A relation is just a set of ordered pairs. So any way that we give you the information, whether it be a horizontal table, whether it be a graph, or whether it be a vertical table, it's just a set of ordered pairs. So there's no worries about that, okay? A relation is just a bunch of data taken from the points that's been graphed. And what they're going to do is they're going to give you this, and they're going to say, would you please list the domain and range of the relationship above? And they might pull this trick. Instead of labeling the X domain, they'll call it X, because they expect you to sit here and go, you know what? I know this is the domain. And I know that Y, another name for that, is the range. So when it comes time to list it, we can say, okay, here's the domain. Put a bracket right there. It would be 8, 10, and 40. And here's the range. It would be 14, 18, and 78. Usually we do make sure that it's listed least to greatest, but my biggest concern is that if they ask you to find the domain and range, you just know they're asking to list all your X's and list all your Y's. When we go down further, here's another thing that we run into at times. Use the equation rule to finish the function table. Well, they give you an equation. This is also known as a rule for the function. And they give you the domain. Well, domain is just another idea for X, right? So if you wanted to, anytime that you see the word domain, you can just like reapply the term X right in its place. So our X values are 0, 2, 4, and 5. So here's our X values at 0, 2, 4, and 5. Okay? So really all it is go find our range or go find our Y values. If this 0 is X, then this 0 becomes, this X becomes 0 here. And 0 times negative 2 is 0, and 0 plus 4 is 4. If the X becomes a 2, negative 2 times 2 is negative 4, and negative 4 plus 4 is 0, because the Y equals 0. Here, we just go through and continue putting in whatever numbers they give us for the domain. So this will be negative 4. And here, let's see, that would be negative 6, because this became 5. 5 times negative 2 is negative 10, plus 4 is negative 6. So that's how we actually complete a function table, and that's not that difficult. The last thing I wanted to spend just a little bit of time on before we recapped it was the following. What if they give you a graph and they say, hey, can you list the range and domain of this function? Well, here's a point. Take its X and Y values and put them into the proper spot. A domain is just an X value. A range is just a Y value. So let's go through and list what we got. X values are negative 3, negative 1, and 3. So this point right here is negative 3, negative 4. So negative 3 is our X value. So we'll just go through and type in negative 3 here, and negative 4 is the Y value, so we'll put that in for the range. Then we go up to the next point. This is negative 1 for the X value and negative 2 for the Y value, so we put them in the proper spots. And the last one right here is 3, 2. This point right here is 3, 2. It's graphed, and so 3 is the X value, 2 is the Y value. So I'll put the 2 down here for the Y value. Go ahead and put the end bracket on there, and I'll put the positive 3 right there. And there we have it. We've been able to list the domain and range of this function instead of giving us an equation like what we had up here before. You know, another name for that would be the rule. They just give us the graph, and we take the x, y's here. If we wanted to list the domain and range, a lot of times they'll give us the domain, and we've got to go figure out the range with this equation. We fill it in. And of course, if we're really lucky, they'll give us a table or some sort of list, and we just have to know that all x values are a domain and all y values are a range. Please remember that relation is just another word for set of ordered pairs. And of course, going back to the beginning, a function is just a rule that defines each input as having one output, and we'll look at that term in more detail tomorrow.